This is lesson number 64 in Algebra 1, called Domain in the Additive Property of Inequality. Alright, so we've got kind of two new things that we're going to talk about, and the first one being the term domain. So just to kind of give you an easy idea of what domain is, let's say that you have a bag of marbles, and you have a red one, a white one, and a green one. So you have 3 marbles in this bag. And I ask you which marble you would like. And you would say, I want the white one. Well, the white one is part of the domain. It's part of your choices. If you said that you wanted the blue one, that would be a problem because the blue one is not part of the domain. It's not part of what's in that bag. So you can't choose what's not choosable. And that's pretty much all domain is the permissible choices that you have. And every equation and every inequality has a domain. But instead of red, white, and green marbles, we may have numbers. And I may say, okay, so out of this group of numbers, let's say the domain of integers. So we've got a set of integers. Now remember what an integer is. It's all the counting numbers from negative, 0, and positive. So negative 3, 2, 1, 0, 1, 2, 3. And I say, okay, pick a number out of there. Well, can you pick 1/2? No, you cannot pick 1/2 because 1/2 is not part of the group that you have been designated to choose from. 1/2 is not an integer. So if I say pick an integer, you're going to have to pick one of the counting numbers that we had been talking about in the last section. Alright, so let's go ahead and look at some examples. And it says graph x is greater than 2, and the domain is the set of real numbers. Now, if you remember, real numbers are all the fractions and all the, fractions and decimals and the counting numbers. So if you're asked to graph that, is 1 part of that domain? No, well, it is part of the domain, but we're only interested in the numbers that are greater than 2. So even though 1 is a part of the domain, just like every other number, it's not following the instructions that we're looking for. So it's like, okay, given this whole bunch of numbers, I just want you to pick the numbers that are bigger than 2. So that means if this is the number 2, all of these numbers along this number line count because they're all bigger than 2. And remember, you put an open circle there on 2 to show that it does not include 2 because it says x is greater. If x is greater, then it's not 2. So an open circle with the arrow to the right showing that we're going to look at all the numbers that are bigger than 2. Fractions, decimals, everything. Alright, let's keep going here. If we're asked, like in the second example, to pick numbers that are greater than or equal to 3, and the domain is a set of integers again, or set of integers, last one was real numbers. Alright, right there it says x is greater than or equal to 3. So x has to be a number that's bigger than or is 3. Now what if I said x is not bigger than or equal to 3? Well, if x is not bigger than or equal to 3, then x must be smaller than 3, right? It can't equal 3 because I just said it can't be equal to 3. So I'm looking at all integers that are less than 3. Alright, integers again are your counting numbers. So these numbers in between 2 and 3 cannot be counted because those are fractions. So the first number that's an integer that's smaller than 3 would be 2, and then 1, and then 0, and then -1, then -2, then -3, etc. Alright? So you have to designate which kind of numbers we're looking at and where they would fall on the number line. Okay, let's keep moving along here. What if I said x is greater than or equal to -1? And the domain is the set of real numbers. Now remember, real numbers include all fractions. Whenever you see real numbers, you know you're going to have a line, not just dots filled in on certain numbers. So x is greater than or equal to -1. So does it include -1? Yes. So then it's a solid circle to show that we're including -1 in our answer. And it says it's bigger than. Bigger always means left, or to the right. Numbers that are bigger than -1. If we would have gone to -2, that's a smaller number because it's in the negative direction. So that would be the graph of that. Keep going here. The next one says that x is smaller than -1, and we're only interested in positive integers. Okay. Draw a number line. We've got 0, 1, 2, 3, 4, 1, 2, 3, 4. We've got -1. So x is smaller than -1. So we're going open circle because we're not including -1, and we're going this way. They want x is littler than -1, which is easy to graph, but then they put some stipulations on it. They're saying that the possible numbers you can use for this answer are only positive. Well, positive numbers start here and go this way. And if you'll notice, that isn't the direction that we're supposed to go. So are there any negative numbers that are also positive integers? No, there are not. So that means there is no answer. So the answer is the null set or the empty set. Okay. Get rid of my null set there. If I'm graphing x is greater than or equal to -5, and the domain is positive integers. Okay, do my graph here, and 0, 1, 2, 3, 4, 5, 6, so there's -5. And there's +5. Okay, it says that x is greater than or equal to -5. So it includes -5, so it's going to be solid. And it says x is bigger than, so it's going to go this way, because that's the bigger than direction. And now I look at my rules. The domain, the numbers that I can include, are only going to be positive integers. So positive integers. There's one, there's one, there's one. Integers are counting numbers, so there's nothing in between. So those are the positive numbers. So what I did is made with my blue dots the possible answer there. Even though this includes all the numbers, the domain, I'm saying these are the numbers you have to choose from, only include the counting numbers that are positive numbers. So the blue dots are the only ones that actually count. Okay, that's what domain does, is it specifies which numbers you're allowed to use in your answer. Okay, and that brings us up to our next part, 64.b. And you already use the additive property of equality and the additive property of inequality. Well, the additive property of equality means that if we have x plus 3 equals 6, you can take 3 from each side and you get x equals 6 minus 3 is 3. Okay, you've been doing that for a long time. Not really a problem. The same is true when you have an inequality. And I tell you what the domain was. Your possible answers are going to be all the real numbers here. So you do the exact same thing. Subtract 2, subtract 2. You pretend like this is an equal sign. 0 minus 2 is -2. And there's your answer. Okay? And then if you're asked to graph that, it's not too hard to graph. You start at -2, and it's an open circle because it does not include -2, and it says it's smaller than -2, so we have a graph that goes that way. Alright, so the next one, which is 64.7, we have x minus 3 greater than or equal to -5, and D is a set of integers. It only includes the counting numbers, negative and positives and zeros, and they're asked to graph that. Okay, so what you do is you solve for x. So we add 3, and we get x is greater than or equal to -5 plus 3 is -2. And we're only concerned with integers. So we draw our graph. So the rule is you're going to solve the problem, or the steps, and then you're going to find out which numbers you're allowed to use based on what your domain is. Okay, so it says x is greater than or equal to -2. Well, x is greater than or equal to -2. It can be -2, and then it's all numbers this way, right? Greater than. Now we look at our domain. What are my choices here? My choices are D is, the domain is only integers. I don't care if they're positive integers or negative, but they're only integers. Which means, and let me make this a little bit bluer and a little bit thicker. Okay, so my choices are integers. Only my counting numbers that are greater than or equal to -2. It does not include the numbers in between because those are real numbers, and we're just interested in integers, which are the counting numbers. So that would be your answer. So the steps are: solve the inequality, graph, then look at your domain. What numbers are included in your domain so that you can actually pick them. So what is going to happen is the answer is going to be a subset or a part of the answer to your equation here. Okay, so you're graphing the equation, and then they're saying, okay, so all those numbers I have there in red work, but I'm only interested in the counting numbers, so just give me the counting numbers. So that's how you get specific on what numbers you're interested in that are greater than or equal to -2. So you find all of them here, and then you're specific on which ones you're really interested in using. And the ones you're specific about are just the blue dots there. All right, so that is lesson 64.